वेलकम ब्याक। आजको फेरि नोट पढ्नेछ हामी। पिन्जा के अरे डिएससीको 137 पन्नासम्म आएको थिएँ। अब 100 पन्ना थियो। अब त्यहाँदेखि तलको पढ्नेछु म। 100 देखि मुनि पढ्नेछ हामी। ल 102 मा आइसक्यो। 102 को हेर्नेछु। यहाँ थियो। Position will search 0 from position in the array 29, 18, 23, 10, 36, 26, 43, 43 as 29, 29%, 11 as 18, 18%, 11 as 23, 23%, 11 as 10, 10%, 11 as 36, 36%, 11 as 25, 25%, 11 at 46, 46%, 11 43, 43%, 11. Disadvantage of linear probing, dusting problem searching is slow. Quadratic probing in case of the collision rears function has value 1 square percentage size has value 2 square plus size and so on. This technique table size 11 given element 29, 18, 43, 10, 46, 54 as 29, 29%, 11, 7 as 18, 18%, 11, 7 has value 1 square percentage 11 7 plus 1 percentage 1 and 8 has 343% 11 has 10% 11 has value 1 square percentage 11 has 46% 11 2 has 54% 11 10 has 1 square percent 11 0 has 10 plus 2 square percent 11 double hashing. This technique require the hashing second time in case of the collision. Suppose hash is the hash key, then in case of the collision we will again do the hashing in the hash key. ASCII will sort the ASCII location H plus H, H, H plus 2, H, H plus 3, H, and so on. Consider the table size, then the two H function are H plus key, H plus key plus 11. At the time of the collision, H address for the next probability H plus H1 percentage 13 key plus percentage 13. 11 minus key percentage 11 percentage 13 H plus 2H or the key H plus 13 2n plus 11 question consider the element a plus 55 48 68 table size 13 as key percentage 13 as 11 key percentage 11 now applying the modulus operation as 18 8 plus 13 as 55 55 plus 13 as 48 48 plus 13 as 60 68% 13 hence the collision occur at the table location 3 so applying the double hashing we get key percentage 13 11 minus key percentage 11 percentage 13 t plus 11 minus 2% 13 12% 13 advantage we do operation faster drawbacks require the two times calculation of the hash function which creative the complex and the sorting will be slower than the linear and the quadratic for probing rehashing there are the chance of insertion of the failure when the hash table is full so the solution for the particular case is to create a new hash table with the double size and the previous hash table. Hence, we will use the new hash function. We'll insert all the element of the previous hash table. So the scan the element of the previous hash table only one open and the hash key with the new hash function and insert them into the table 10, 36, 25, 7, 18, 43. Consider the table size 11 and the element are size 11 h 7 h 18 h 43 h 10 h 36 h 25 as percentage 7 11 as 18 percentage 11 as 43 percentage as 10% 11 as 36% 11 as 75 25% as 7 as 18 as 43 as 10 as 36 as 25 disadvantage this method is a more expression web graph or graph B is the collection of the two set B and the E where the B is the collection of the vertex B0 B1 and B and N1 is the node and E is the collection of the E's E1 and E2 or the E and R the word and is an arc which connect the two nodes. This can be represented as G, B, E, B, G, B, O, B1, B or the set of the vertex EG, E1, E2 or the size set of the vertex directed or undirected graph which has undergone the pair of the vertex is called the unit directed path. Suppose there is an edge between the B0 and B1, then it can be represented as B0, B1, B1, B0, B0, 1, 2, 3, 4, EG 1, 2, 4. 1 3 2 3 2 4 3 4. Directed or directed graph or the digraph is a graph which has ordered the pair of the vertex b1 and b2, or the b1 is the tail and b2 is the head of the each. B1 b2 bg 1 2 3 4 eg 1 2 1 4 1 3 2 3 2 4 3 4. Weighted graph or graph is said to be weighted if the each has been assigned with the some non-negative weight adjacent with the node u is adjacent to the ender node or the neighbor of the ender node. If there is an is up from u node b in the unit directed part, if the b0 b1 is an is, then the b0 is an adjacent b1, and the b1 is an adjacent to b0 in the diagram. B0 and B1 is an is, then the B0 is an adjacent to the B1 and B1 adjacent from the B0. A path from the node U0 to the node U1 is a sequence of the node U0, U1, U2, Un minus 1 such thing. U0 is an adjacent to the U1 and is adjacent to the U2, and N minus 1 is adjacent. Length of the path. Length of the path is the total number of the edge included in the path. Closed path. A path is said to be closed if first and the last node of the path are the same. 1, 2, 3, 4. Simple path. It is the path in which all the nodes are distinct with an exception in the first and last node, and the path can be same cycle path. In the cycle is the simple path in which the first and the last node are the same. A0 cyclic path. A graph has no cycle called the cyclic path degree. Mm. In an unit-directed graph, the number of these connected to a node is called the degree that the node or the degree of the node if no of the number of the incident on it. In degree of the node number of these coming out of the node A0, B2, BC2, D6, E1, F0, G1, A3, B1, C1, D0, E2, F3, G2, A, B, C, D, the successor or the predecessor in the graph. If a node B is adjacent to the node B1 and B0, the predecessor of the B1 and B1 is the successor of the B0 connected path, then unit directed graph is connected. If there is a path from any node of a graph and to other node, graph G1 is connected to the G2 and unit unconnected path is strongly connected. A graph or digraph is strongly connected if there is a directed path from any node or the graph of the node to the other node weakly connected. A diagram is weakly connected from any pair of the node U and B, and but there is a path from the U to the B or in the path from B to U. Not both. The minimum is in the graph on in unit directed graph. Maximum is n minus 1 2. In the digraph, maximum is n minus 1 when there is a total number of the node in the graph n minus 1 2 3 at minus 1 2 3 n minus 1 3 3 minus 1 representation of the graph to a sequential representation. Adjacency matrix linked list representation. Adjacency list adjacency matrix is the matrix which gives the information of the adjacent node, i.e. that gives the information whether the node is adjacent to other node, or the suppose that there are the four node in the graph, then the row represent and the row 1 and the row 2 represent the node and so on. Similarly, column 1 represents the node 1 and column 2 represents node 2 and so on. The entry of the matrix will be ARR if there n is of the node and node J, and the there is no is from node to the node J A0 0 A1 0 0 1 1 0 1 1 0 0 0 0 1 1 0 1 0 1 2 1 2 3. For the unit directed graph 1 0 1 1 1 1 0 1 1 1 1 0 1 1 1 1 1 0. It has no degree out degree because it has no direction of the most representation of the weight graph in the matrix form. If the graph has the sum weight on its is, then weight on the edge if there is an edge from I to node. Otherwise, weight is adjacency matrix are degree 0 3 0 9 0 2000 0 4 0 6 0 8 7 50. Walser algorithm is for finding the matrix of the graph. Algorithm initialize perform pass repeat step through 4 from K1, comma 2 forces repeat step for the 4 forces column repeat 1 to UPK return from the graph out of the print is 1 1 1 1 0 0 1 0 1 1 1 1 0 EPK PIJK A0 A is 1 1 1 0 1 1 1 0 1 1 1 0 1 1 1 1 1 1 P A B C D A 1 1 1 0 1 1 1 0 1 1 1 0 1 1 1 1 0 1 taking K A, B, C, D, P is the adjacency matrix and the PU is the part of the matrix modify. Warsaw algorithm give the path of the matrix by modifying this algorithm. We will find the shortest path matrix Q. Qj is the represent the length of the shortest path Bi and Bj. Here we consider the matrix Q0, Q1, Q2 shortest part of the Bi and Bi using the node Bi, B2 and the B1 and there is no path considered in this algorithm. Length of the first part will be Qk, length of the second part will be K minus 1. Select the smaller from these two paths and length of the value minimum. Algorithm adjacency matrix 0 replaced by 0. Perform the pass repeat through the step 4 for the K1, 2, 0 process row repeat 4 from 1, 2 process column repeat J1, 2 K K mean K I J K Q finish return I J I Q K then Q K and then the QKIJ minimum, QKIJ and QKJ is the cube for transverse in the graph. There are the two efficient techniques for the transversing the graph. The depth first is sorts of breadth first sorts the difference between the transverse in the graph and transverse in the tree. For us, there is no node for the root node in the graph, hence the transversal can be start from any node in the any tree where we can start the transferring from the first node. All the node are transfer which are reachable from the starting node. If we want to transfer all the reachable in tree the list while transversing, we will never encounter a node more than once, but in the transfer there is only one sequence which node are visited, but in the graph the same technique of the transversal there can be different sequence which node can be visited. First source, the technique uses the cube for transferring all the nodes of the graph. In this, we take any node as a starting node. Then we talk all the node adjacent, and that the starting node. Similar approach we can take for all the other adjacent node, which are adjacent algorithm. Mark all the vertex on visited. Begin with the node. Insert with the queue. Initial. Remove the node from the queue. A pin from the transfer is to mark it visited. Insert on visited or the node sort on the queue in the same queue. Repeat the step 3 to the 5 until the queue is empty. Finish. Return 2 8 3 5 8 3 5 6 7 3 5 6 7 5 6 7 6 7. The transfer depth first search the technique used the stack for transferring all the nodes of the graph. In this way, we take the starting node, then the part which is the starting node, visit all the node, and we reach the last node. Then the transfer another part is starting from the node. There is no path in the graph from the last node. Then it returns to the previous node when the path transfers another, and so on. Algorithm transfers question 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. Breadth first in the transfer depth first 1, 4, 5, 2, 2, 5, 3, 4, 7, 5, 8, 6, 6, 5, 8, 5, 8, 9. Transfer 1, 4, 7, 5, 8, 9, 6, 2, 3. Shortest path algorithm used to find the shortest path from one node to the another node. A single source vertex in the six shortest path to all the other vertex shortest paths in the path which with the sum of weight is included is the minimum path. A shortest path the discards algorithm in this technique is node is labeled with the distance dist for predecessor status. Distance of the node represents the shortest distance of the node from the source node, and the predecessor of the node represents the node with precedence from node in the shortest form of the source and the node, and permanent or the temporary shaded circle represent the permanent node, which indicate that it has been included in the shortest path. Consider initially make a source node permanent, make it the current working node, and all the other node temporary. Example, all the temporary neighbor of the current working node after checking the condition for the minimum weight reliable and the required rule from the temporary node. Find out the node with S minimum value of distance, make a node permanent, and now this is current working node. Repeat step 2 and step 3 until the destination node is made permanent. Destination pre-node status permanent, temporary. Check the adjacent node of the B tree. This advantage is status permanent, temporary. The status permanent, permanent, temporary status permanent, temporary. Check the node status permanent, temporary, permanent, temporary. Check the adjacent node of the B5 status permanent, 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 temporary. Snapping tree. Since the minimum spacing trees will contain the n minus one is where n is the number of the node and in the graph and a graph contain the niche node. So after inserting the 80 is in the spanning tree, there will not examine the other is and the stop the process here. The is include the spacing tree are 1 5 4 5 3 6 5 6 2 5. Spanning tree Robin algorithm initialize the spanning forest maintain each is find the practical tree, combine, repeat the algorithm in the queue. A greedy algorithm consider the problem of making the chances assume the cosine and the value of 25 and the and the penny. Suppose we want to return the algorithm probability is to select the largest will whose value was not greater than 63 and add it as an extract from which 63 is 30th. The 63 minus 25 the method of making the charge is the greedy algorithm at an individual state is a greedy algorithm select that option which is locally optimum in the same particular scene. We have seen the several greedy algorithms such as a discat shortest path algorithm, CRISPR minimum cost spanning tree algorithm. CRISPR algorithm is also greedy as it picks from remaining is the shortest among those program of the stack using the array defined max in top in stack array max minimum in choice while print fpsf pop print 3 display print print enter your choice. Scan a percentage choice push pop display exist wrong choice void push into post pushed item max print app stack overflow print app print the circular queue insert in the define max into queue rlx list in front in rear main in choice while print app insert delete display quite enter your choice choice insert break deal display break exit print wrong choice in front front rear if rear plus one print ip plus element in the queue plus d item queue array item at least in front print queue underflow element deleted from the queue percentage d in queue r front var front one minus rear minus one yields if front a max minus one front if front plus one display in front post front rear post rear print the queue is empty if front post rear while the front post rear printf queue array front post while the post rear output insert delete display quite enter your choice input the element for the insertion in the queue delete quite enter your choice input define max in queue dq in right margin in choice printf ip restricted dq restricted queue enter your choice dq choice input queue print default queue um, right zero yields right plus one if the element for the adding in the queue edit item right edit item insert live insert edit item left queue print queue overflow left minus one left zero right zero yields if left zero left max minus one left minus one print app template for adding one template for edit item delete phase queue underflow element deleted from the queue percentage d in packs minus one left print q underflow element deleted from the q percentage d dqarr right a program of list using the array define max int array max int main choice in temp post print and insert display source display quite interview choice break enter element to be search found in the position element not to be found delete break display break exist break default print wrong choice input in 0 ip value for the element percentage d insert return 0 insert in temporary in term position print enter the position for the uncertain percentage d and the position enter the value enter percent d and the item if position n plus 1 enter the position less than or equal to n plus 1 return if position n plus 1 array item n plus 1 return insertion in between array position array minus one print f scan f enter the element to be deleted scan f percentage d item per item array n minus one return position search item if position print element is not present array return deletion in between temporary position minus one while temporary n minus one array n minus one display into one print list empty return I0 I n n plus 1 value of position program or the singly listed include stdi.h malloc.h stock node in print info stock node link start main in choice m position while start null create printf how many node do you want scanf percentage d for I, the I print f an element scan f for and print enter start null print f list is empty continue print enter the element for the deletion printf insert the element to be search scan f percentage d search and break exist default print wrong side int switch struct node malloc info data int link null if it is list is empty return in and create list add back a strict temporary malloc size struct node temporary info data start temporary add after int data int post struct node temporary queue int I Q start for I Q post one link null there are less percentage d element return in for temporary malloc size of the struct node temporary link Q link data info temporary return struct node if the start info data temporary start link temporary return while Q in Q dq in Q dq pre temporary Q link return f element not found in the data display struct node if start null list is empty list null empty think number of element percentage the int count struct node struct print link null link print 2 3 link start 2 3 source link source link print the return item and percentage found at the position percentage d data post ptr link post plus plus if ptr equals to null if item percentage d not found in the list data percentage data end of the search. Okay, this much for today for data structure and algorithm. आजको मैले पढाएँ मैले पढेँ केही नि बुझिनँ